so we looked at our first three tips. Like we said, we have right, left, and midpoint. However, none of those were like great approximations. They weren't bad, but we actually have a fourth type of approximation, and it is trapezoid. And as it sounds, if I have some graph, so we'll just stick with like our x squared graph that we were kind of looking at before, something like that. Yes. We can make rectangles, but what we can also do instead, we're going to use the left-hand side as one of our points, but then we're going to use the right-hand side as our other points. And now we're going to make trapezoids instead. Yes, no, maybe. So especially with our strictly increasing or strictly decreasing things, trapezoid approximations can be pretty accurate, which is why we have them. So what we're going to be doing is using the left x value of an interval for f of x sub 1, which is going to be kind of like our base 1. Which is acting as our base 2. Because then our areas, okay, remember from our trapezoid thing that we talked about earlier, is base 1 plus base 2. But for us, that's going to be f of x sub 1 plus f of x sub 2 divided by 2. So those are acting as our base 1s and base 2s. And then we still have to multiply. This time it's the height, but because our trapezoids have kind of been knocked over on their side, our heights for each of our trapezoids actually ends up being our widths of our interval. And remember that we said that the widths we label as the change in x. So we're going to be using that formula now instead. Yes, no, maybe? Yeah. Alright. So let's plug in the example. So this is approximate the area under f of x equals 4 natural log of x on the interval 4 to 10 using 3 trapezoids. So what function are we using? 4 natural log, okay? Then we need to decide on our widths. So remember that our widths are our change in x, and we said that that is b minus a divided by n. So we're going from 4 to 10. So recall that those are my b and my a, and then how many trapezoids or intervals do we want? 3. So what are each of our widths going to be? 2. Okay with that? Okay, which, if you want, you can draw a graph of this if it's helpful. So, use 2, 4, 6, 8, 10. This is a logarithmic graph. So it's going to go 1 and then curve up like that. So we're starting at 4. So we get something that looks like that. So we're going to go from 4 to 6, 6 to 8, and then 8 to 10. Are we okay with that? And remember that we find those heights by plugging in into our function. So, what did we say our widths are this time? 2, right? And they're going to be the same for all of them. So we can go ahead and factor that out. Yes? The only time that we have to multiply them separately is if they're like different widths. Okay? So then we have base 1. So base 1 for my first trapezoid is what I get when I plug in 4 into my function. So we're just going to leave it as 4 natural log of 4 for right now. Then I'm going to add my base 2, which is what I get when I plug in my right hand value, which is 6. So I have 4 natural log of 6 divided by 2. And that would be the area of my first trapezoid. And then the nice thing about your trapezoid approximations is notice that the base 2 of my first interval is going to be the base 1 of my second interval, right? They're always going to like overlap like that, except for your ends. Which means that, I'm going to add, it's going to be 4 natural log of 6 is going to be my base 1 for my second one, plus 4 natural log of 8 divided by 2. And then lastly, we have 4 natural log of 8 plus 4 natural log of 10 divided by 2. Yes, oh big. Now notice if I'm dividing each of those by 2 and I also have a 2 on the outside, what's going to happen with those? They're going to multiply to give me 1. Or I'll give it back. Yes, so I have 4 natural log of 4. And then how many natural logs of 6s do we have? 8. And then how many natural logs of 8s do we have? Also 8. And then I have 4 natural log of 10. Now, this was a non-calculator active question, especially like a multiple choice question. They would probably simplify it, and so this would be your answer. If it was a non-calculator active free response question, we could have just left it here. We didn't have to distribute or do anything like that. If it was a calculator active question, we would then plug it into our calculator and get a decimal approximation, because those natural logs aren't going to be super pretty numbers. So what do we get if we do that? Huh? 45.725. And again, like we don't have units, so it's just that is the area under the curve. What questions do we have there? So our trapezoid rule is pretty similar to our left and our rights and our midpoints. The only difference is them plugging into trapezoid areas instead.